Friends, I Abhinav welcome you all in BYJU'S Exam Prep YouTube channel, and this session today guys, we will be doing the complete geotechnical engineering formula revision in one go. When I say geotechnical engineering, that means soil mechanics plus foundation engineering. And guys, no need to write anything. Okay, usually when I come live, I say to the students, then guys, please be ready with your copy and pen. Okay, but in this session guys, no need to write anything. Just be in a sitting position, and then after that guys, whatever I'll be writing here or whatever the formulas will be here, I will be sharing it in my Telegram group, that is Civil by Abhinav sir. Okay, so no need to write. And guys, one small request, the whole team has done a lot of effort to make all these things possible on the YouTube. So please like and share the session so that more and more students can join in. Yes, Sudha, Rotila Saab, everyone welcome guys. Okay, this is about me. I have done my MTech from IIT Delhi in geotechnical engineering. Okay, from IIT Delhi I have done the same subject in which we are doing right now the session. Okay, so you can also connect me in my email ID abhinav.negi@byju's.com, or you can also join me in my Telegram group Civil by Abhinav sir. Okay guys, this is the Sunday ka fun that will be coming tomorrow at 10:30 AM. Okay, morning this time. Okay, the two types of flyover I have been today in the site, and I have recorded some videos that will be tomorrow, and tomorrow morning will be this and evening will be the interview guidance, okay, for engineering service students. Okay, then surveying formula will be on Monday. This is my Telegram group. Here I'll be sharing my PDF of this session. Total more than 5,000 students have already joined. You can also join guys. Okay, so excited for this session guys. Please put a heart sign on the comment section. Let me have some energy of the students guys. Whatever the energy you're putting on the comment box guys, that will boost up my own energy as well. Yes, 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 yes. Excellent. Okay. So before going further, let me tell you the weightage of the soil mechanics. It is not one of the highest weightage of civil engineering subjects. It is the highest. Okay, usually it comes of 14 to 15 marks if you take set 1, set 2. Even for 2022 and 23 it is same. Okay, even for 2022 and 23, the weightage is, it comes of 15 and 16 marks respectively. Okay, 15 and 16 in 22 and 23 guys. Okay, so from both sets. Okay, now if I see about that from, one more thing before going further, guys, see, usually the teacher is very possessed with his subjects. Okay, guys, this is the highest weighted subject, not one of the highest, this is the highest, but doesn't mean that it is as scoring as other subjects, because in my way, surveying, OCF, hydrology, highway engineering are much more scoring than this, because suppose highways survey is coming of 5 marks. Okay, and soil is coming of 15 marks, but the syllabus of survey is less than 1/3. So with reading less than 1/3, it will be 1/5 of geotech, and marks are 1/3. So what I believe, that survey is more scoring than geotechnical engineering. Yes, these are the distribution. You can see that geotech and environment are the highest weightage, but these subjects like survey, hydrology, okay, these highway here are not very vast syllabus, but still they are very, very scoring. Now from soil mechanics, the maximum questions are asked from the soil relationship, that phase diagram. Even the question is not asked from there, still it is very important, because in every soil mechanics, foundation, consolidation, and all these terms will be used. Okay, then seepage, consolidation, shear strength and shallow foundation are the most asked topic in last 5 years. Last update in the syllabus was in 2020 for the 2021 exam, which was conducted by IIT Bombay. That time origin of soil and soil structure, that is coelite, monothermal, mineral, has been deleted from the GATE syllabus, and origin of soil, that physical weathering, chemical weathering, and lateral capacity of pile has been added. Westergaard is also deleted that time. Bozingu is still there. Okay, now this is the correct sequence. If anyone is want to know that what is the correct sequence of consuming the various chapters, okay, there are various chapters. Now in what sequence one should consume all those chapters, then this is the sequence in which you should go. Okay, origin of soil, then classification, then soil structure, this is only in ESE, then compaction, effective stress, permeability, seepage, vertical stress, consolidation, shear strength, earth pressure, stability of slope, shallow foundation, deep foundation, and soil exploration. Okay, that is the quicksand condition. That is the quicksand condition when net stress is 0. Okay, we'll come there guys. And if I compare the GATE and ESE syllabus, then origin of soil and soil structure is only in ESE, yellow color only in ESE. Apart from all other topics are in GATE and ESE both. Okay, there is one more topic that is only in GATE. Okay, only GATE, green color. That is lateral capacity of pile. Lateral capacity of pile. This is only in GATE syllabus. Okay, now we'll going with the first chapter first. Okay, so we'll completing both soil mechanics foundation. Guys, please put a heart sign on the comment box. Please tell me that you are ready. Everyone on the comment section, guys, come on. Ready? Ready? Okay. So let's begin the formula. No need to write anything, because whatever I am telling you, just after the session, just after 5 minutes after the session, I will be sharing the PDF. Okay, I'll be sharing the PDF. So no need to worry about that. Okay. So guys, first chapter, let us go. Okay. So this is, guys, let me again tell you, this is only formula. Okay, I'll not be going in derivation in this session. So guys, anything less than 80 mm is soil. More than 80 mm is not soil. 80 to 300 mm is cobbles. Greater than 300 mm is boulders that are not in the soil category. Then soil is less than 80 mm. So 80 mm to 4.75 mm is gravel. And 4.75 mm to 75 micron. 75 micron is also 0.075 mm. This is coarse grain soil. Okay, this is coarse grain soil. No need to learn these further bifurcations. 80 to 4.75 mm gravel and 4.75 mm to 75 micron is sand, guys. Now below 75 micron is the Lakshman Rekha. Above that coarse grain soil, below that fine grain soil. 75 micron to 2 micron is silt and less than 2 micron is fine grain soil. Now coarse grain soil is having lesser void ratio. This is having higher void ratio. This is having higher surface, specific surface area, more surface area per unit volume. Of course, they are finer, so more surface area per unit volume. Yes, if we consider void ratio, then fine grain soil has a bigger void ratio, because there are small voids, but there are a number of voids such that volume of void becomes more here. But if we talk about one particular void, that is more in coarse grain soil. Permeability is more in coarse grain soil. That all values I will be telling you when we are going further. Okay, fine grain soil characteristics are depending on water content. A slight fluctuation in water content here will cause a large change in the properties. Coarse grain, this is related to water content. Water content is very influential here. And here it is gradation. Gradation, like well graded, poorly graded. Well graded means that different size particles are there. Medium, large, small, very small, very small, XL, everything is there. So that small voids can be filled. And poorly graded means all particles are of same size. So small particles are not there to fill. So uniform soil having almost same diameter are also called as poorly graded soil. Okay, so that is important here. Why it is not important here? Because you cannot say a fine grain soil poor if the size are same. Because fine grain soil are cohesion. Even in fine grain soil, if all particles are of same size, if all particles are of almost same size, that means the smaller particles are not there to go in the voids. Smaller particles are not there. Still you cannot say it poor in fine grain soil, because in fine grain soil has cohesion. So cohesion means still there is bonding. So दूर से देखा तो तुम्हें लग रहा था यार ये तो बेकार soil है, small particles are not there to fit in the voids, but actually if you see from microscope, there is the attraction between the particles, that is cohesion. It is like दूर से देखा तो गंजे खेल रहे थे, पास जाके देखा तो अंडे उबल रहे थे. Okay, so fine grain soil has a flaky structure and charge distribution is there. Yes. Moving further, guys, this is a dry state. Not Gujarat guys, dry. This is when voids are filled with water, and some are water, some are air. So it is called partially saturated. A new name is also coming in the market these days, that is partially dry. Okay, sometimes students got confused by seeing the word partially dry. partially saturated. If partially it is water, then partially dry also. Okay, and it is saturated. Guys, void does not means air. Void means air plus water both. Air plus water both. And guys, please listen one thing, that volume of solid or weight of solid will be constant. Solids will be constant. Suppose I take the soil from somewhere, I excavate it, I take the soil and I put it somewhere. If I compact it, might be total volume decrease. Might be the total volume is decreased if I compacted it. Okay, might be total volume is decreasing. But solids is not changing. Only voids will be decreasing or increasing. The solids will be going to be constant. Okay, guys. Moving further. Any doubt till here? You can ask me, guys. If any doubt you are having. No doubt. Excellent. Okay. Now, what is water content or moisture content? Guys, water content I'll be representing with small w. With capital W I'll be representing the weight. Okay, but small w I'll be representing the water content. That is weight of water. Capital W means weight. I'll be representing weight of solid into 100. And guys, water content can be greater than 100%. Okay, can be greater than 100%. Yes, it is possible. Might be there are so much voids and the volume is so much of voids that weight of water is becoming more than weight of solid. So this might be a possibility. Okay, now going further guys, come on. Guys, see, total weight is weight of solid plus weight of water. Capital W means weight of air. Weight of air is taken as 0. Okay, what is total volume? Total volume is volume of solid plus volume of water plus volume of air. Volume of air is not 0, guys, and water and air are voids. So this is volume of solid plus volume of voids. Volume of solid plus volume of voids. Now, what is void ratio? Represented by E. E is equal to void ratio. E is equal to volume of voids by volume of solid. E is equal to, guys, no need to write down. I'll tell everything. My PDF I'll be sharing every of these things. Okay, guys, everyone. Okay, don't be writing all these things. Now one is porosity. N is porosity. So N is volume of voids by total volume. Guys, which will be bigger, E or N? Tell me please. What will be bigger, E or N? What will be bigger, void ratio or porosity? Void ratio or porosity? Tell me on the comment section, guys. Every one of you. Of course, E will be bigger than N. What is the relation? That I'll tell you. E is equal to N upon 1 plus E. That I'll tell you later on. Because here the numerator is same, volume of voids, but denominator is bigger here. But E is more widely used. E is more widely used. The reason being, here the denominator is volume of solid. And volume of solid is constant. So E is a more stable parameter. Because in E the denominator is volume of solid, which is constant parameter. Okay, when we transport the soil from one place to another place, okay, so voids may decrease, but solids are not decreasing. Okay, what is the relation between E and N? That I'll tell you later. E is equal to N upon 1 plus E, N is equal to E upon blah, blah, blah. Okay, that I'll tell you later. Now degree of saturation is represented by S. Okay, degree of saturation is represented by S. This is volume of water from the total voids. Okay, volume of water from the total voids. Okay, now here guys, in the dry state, S is what? Volume of water by volume of voids. So no water here, S is equal to 1. Here in partially saturated soil, it is between 0 to 1, and saturated soil, the S value is 1. In saturated soil, the S value is 1. Now moving further, okay, this is the this is the saturation, degree of saturation, volume of water by volume of voids. Now one thing is air content. Okay, air content is represented by AC, and AC is volume of air with respect to volume of voids. Please check, S plus AC is equal to 1, because volume of water by volume of voids, okay, plus volume of air by volume of voids. So volume of water plus volume of air is volume of voids only. So volume of voids by volume of voids is equal to 1. Okay, 1, or you can say if you are talking in terms of percentage, it will be 100%. Air content we have done. Now percentage air void, NA. So percentage air void is volume of air upon total volume. Okay, air content was volume of air with respect to volume of voids. This is with respect to total. Now guys, these terms are there. Bulk unit weight is represented by gamma T. Unit weight of solid is gamma S. This is gamma W. Dry unit weight of soil is gamma D. Nothing need to remember, yaar. Gamma is weight, density is mass by volume, na? Density is mass by volume, na? Similarly, gamma is weight by volume. That's it. Density is mass by volume. Gamma is weight by volume. That's it. That's it. Okay. Now, like it is gamma of bulk unit weight means refers to soil. So gamma T means weight of soil upon volume of soil. Unit weight of solid upon volume of solid. Unit weight of water, gamma W, weight of water upon volume of water, weight by volume. Dry unit weight of soil. So dry unit weight of soil means weight of dry soil, and weight of dry soil will be equal to weight of solid, na? Because when soil will be dry, only solid and air is there, and weight of air is 0. So weight of dry soil upon volume we have to write total volume of soil, but weight of dry soil is weight of solid only. If dry water is not there, and air weight we take 0. Okay. Similarly, saturated unit weight means when the soil is saturated condition. In this case, weight by volume is gamma sat, and there is some of, I will be having some density. Okay, I am having some density. If I go, you can not lift Vidya Balan, but in swimming pool might be you are lifting her, because in swimming pool, if she is inside the water, then beyond weight is acting. Similarly, normally it is gamma sat, weight of saturated soil by volume, but when the soil is below water table and beyond weight is acting, then that beyond weight is called as gamma submerged. And gamma submerged, I am not going derivation, many times I have done the derivation of this. So this session will be more oriented towards the formula, guys, not derivation and not that other things. Gamma submerged is equal to gamma sat minus gamma W. Okay, guys, keep sharing the session, guys. Let it make it bigger. Good evening, Amrish. How are you? Good evening, Amrish. कैसे हैं? विनोद भाई, सबको एक बार शेयर कर देना. अमरीश एक बार सारे सेशन में, एक सारे टेलीग्राम में शेयर कर देना, ठीक है? चलो. अब स्पेसिफिक ग्रेविटी ऑफ सॉलिड क्या होगा? स्पेसिफिक ग्रेविटी ऑफ सॉलिड इज गामा. स्पेसिफिक ग्रेविटी मींस, स्पेसिफिक ग्रेविटी 2 means that material has 2 times more density than water. Specificity 5 means that material has 5 times more density than water. Specificity 10 means that material has 10 times more density than water. Specificity 1 means the material has same density as of water. Specificity 0.5 means the material has a density of half density with respect to water. So specific gravity of solid means gamma of solid with respect to gamma of water. This is also called as GS. In soil this is used. Wherever in soil the formulas you are seeing G na, that is specific gravity of solids. That value is around 2.6 to 2.7. Specific gravity of soil, that is specific gravity of soil, GM, that is gamma of soil with respect to gamma of water. This is gamma of solid with respect to gamma of water. Okay. Now guys, one more thing. I'm writing something. The maximum density will be of solid. Then it will be saturated soil. Then it is bulk, considering the, what is bulk means? Bulk means whatever the existing condition. It is saturated, it is dry, it is partially saturated. Gamma bulk means whatever is the soil, general case. Okay, then so we should put equal to sign also. If it is saturated, then gamma sat and gamma bulk both will be same. If it is dry, then gamma bulk will be gamma dry. Gamma bulk means whatever the existing condition is. Then gamma submerged will be least. Guys, of course here, I hope you understood this. Guys, all these things are for soil. Gamma saturated is for soil. Gamma T is for soil. Gamma dry is for soil. Gamma submerged is for soil. This is not for soil. The gamma solid means only solid. This is the average marks of all subjects. Physics, chemistry, math, English, Hindi, everything. In English, dabba goal hai. And this is the marks of only science and math. Usually got higher. Oh, gamma solid means only density of solid. ये आया ही नहीं ना, ये वाला portion आया ही नहीं, हल्का वाला. But this means the whole density. Gamma solid means only density of this. Give me yes or no in the comment section, guys. Give me yes or no in the comment section. Everybody. Okay. Share करते रहना भाई. इसके बाद अब relationship और different parameters पढ़ते हैं. तो एक एक करके मैं पढ़ाता हूं. एक तो गामा डी जो होता है that is gamma bulk upon 1 plus small w. Can you tell me what is small w? On the comment section, especially the students who joined me late. Okay, what is small w? Water content. Okay. N is equal to E upon 1 plus E. N is what? What is N? Porosity. I told you, yaar. Okay. And if you rearrange these formulas, then void ratio is porosity upon 1 minus N. Okay, sir, got it, sir. Now, Sehwag formula, S saturation into void ratio is equal to W into G. G is specific gravity of solid. 2.6 to 2.7 इसकी value होती है. G is specific gravity of solid. Okay, sir. Got it, sir. Okay, one other formula I told you, S plus AC is equal to 1. Now, gamma bulk is G plus SE into 1 plus E into gamma W. SE you can write down WG. So, when you write WG, G is common. So, this formula will be changing to this. Okay, I have written SE as WG. So, G will be common and it will be like this. Now, for gamma dry, S will be 0. So, put S is equal to 0 here. G upon 1 plus E into gamma W. And gamma dry has this formula also and this formula also. G into both are same. Okay, for saturated, put S is equal to 1. For saturated, put S is equal to 1. So, G plus E upon 1 plus E into gamma W. Now, gamma submerged is gamma sat minus gamma W. Gamma submerged is gamma sat minus gamma W. So, in this you subtract gamma W, you will be getting G minus 1 upon 1 plus E into gamma W. Into gamma W. Okay. Now, guys, one formula which has been asked and many students that time in the gate has not able to do. Guys, all these formulas, what is gamma sat? Gamma sat is equal to G plus SE upon 1 plus E into gamma W. Correct, friends? Okay, sir. Now, if the voids are not saturated with water, if the voids are saturated with some other liquid, jam, sauce, heavier or might be lighter, the density will not be same, na? Guys, if this bottle is filled with water, bottle volume has constant. So, filled with water, it will have different density. Filled with beer, it will be having different density because weight will be different, might be little lighter. If this bottle is filled with jam, it will be having a higher density because volume is same but weight is more. Similarly, the liquid which is going into the voids, that is a deciding factor for the density. So, if it is water, the formula is this. If it is some other liquid, then for saturated, this S should be 1, na? This S should be 1. Okay, this S should be 1, G plus E. If the voids are filled with another liquid, then the formula is this. Here G dash is the specific gravity. Here G dash is the specific gravity of that liquid which is filled in the voids, and this time a question in effective chapter in GATE has been asked from this. Okay. Now there is one more formula, like gamma D is equal to 1 minus NA, NA is percentage air void, G gamma W upon 1 plus WG upon 1 plus WG. Okay sir, got it sir. Okay, so phase diagram is complete. Now let us go to the grain size distribution. We put the soil, generally 1 kg soil in the sieve, and then we shake it for 30 minutes, 35 minutes, and different particles are coming. So of course, if the bigger sieves are at the top, then bigger will be here, then smaller, then smaller, then smaller. Then we shake this for 10 minutes. Okay, we take 1 kg of soil, shake it for 10 minutes, then we take different sieves, and from different sieves we take the weight, and of course the weight of different sieve will be different. Okay, so from there we can find out the diameter of various particles. That is a table. Okay, that I'm not going into the table because this is a formula oriented session. Okay, Shubham, Vinod, excellent guys. Okay, now moving forward. Okay. Now moving forward. मैच में बारिश आ गई ना? मैच में बारिश आ गई लग रहा है. ओके चलो, अब एक होता है, ये हमेशा ग्राफ ऐसा आता है डिक्रीजिंग लॉग डी का. ओके, बड़ा डायमीटर यहाँ रखते हैं, फिर छोटा यहाँ और छोटा यहाँ और छोटा यहाँ. लॉग में क्यों रखते हैं? Why this scale is in log? Because diameter has a huge variation. 80 mm for gravel, and for sand it is going up to 0.075 mm. Then for clay it is less than 0.002 mm. So very huge variation. So that huge variation will be coming in log scale only. And this will be always a decreasing graph because the percentage which is bigger, 90% particles are finer than a bigger diameter. Okay. And 70% particles are finer than comparatively smaller diameter. Okay, like this. If the graph is like this, that means all particles are coming, it is well graded. If the graph, this is well graded, because all particles are coming now, more is the flatter the curve, that means a huge range of diameter is present. If the graph is like this, then this means that all particles are in this range only. So this is uniformly, or it is called poorly graded. And if the graph is something like this, then it is gap graded. Okay, between this diameter and this diameter there are not much particles, because this diameter 30% particles are finer, suppose, and this diameter also there are 30% particles are finer. That means these and these, there is no particle or no diameter below this. Okay, now there is a term called CU. CU is coefficient of uniformity, that is D60 by D10. D60 is that diameter below which 60% particles are there. See, what is D30? Below which 30% particles are there. What is D60? Below which 60% particles are there. What is D10? Below which 10% particles are there. What is the, randomly I am taking 44, below which 44% particles are there. What is D72? That diameter below which 72% particles are there. So CU, coefficient of uniformity, is equal to D60 by D10. Okay. And CC, that is coefficient of curvature, is D30 square by D60 into D10. Now for well graded soil, for sand, if CU is greater than C and CC is in this range, both should be happening. And means दोनों होना है. Okay. Okay. And means दोनों होना है. दोनों हुआ तो well graded. अगर एक भी नहीं हुआ या दोनों नहीं हुए, then it will be poorly graded. Okay. Then it will not be well graded. Okay. So similarly for gravel, if CU is this and CC both are happening, then it is well graded. Otherwise it is, if even one of them is not fulfilling the criteria, then it is not well graded. Guys, can you tell me what D50 means? D50 means mean size. Mean size, that diameter below which 50% particles are finer, that means 50% are bigger, so it is mean size. And what is effective size? Can you tell me on the comment box? What is effective size? What is effective size? What is effective size? Tell me. Tell me, what is effective size? D10, D10, D कहाँ गया? अबे तुम गायब कर दे रहे हो मेरे पीछे मुड़ते ही. D10. Okay. So guys, hydrometer and pipette I am not telling the formulas because बिना समझाए उसको कुछ होगा नहीं. हाइड्रोमीटर पिपेट का मैंने डिटेल डेरिवेशन वाला वीडियो लिया है इसी चैनल पर, तो आप सर्च करके अभिनव नेगी हाइड्रोमीटर पिपेट यू कैन सी, वे डिटेल में मैं आपको बताया है. नाउ गाइस, इफ आई मेक अ ग्राफ ऑफ वॉल्यूम एंड वाटर कंटेंट, then it is initially constant and then it is increasing like this. Guys, why initially constant? Because if water content is 0, that means solid and air. Little bit water content I increase, solid will be same, little bit water and little bit air, but volume will be equal to Vd only. Although here the volume is not dry, but volume will be equal to Vd. Okay, only water is coming, air is getting less. Similarly, shrinkage limit, all voids are filled with water, then no air void is there. Further if I increase, then the water will be increasing. Okay guys, can anybody, I want to see that who is the brilliant student in my class. I want to see. Guys, can anybody tell me why in every book this is a dotted line like this? Why dotted line is like this? Why dotted line is this? This. The reason being, can anybody tell me why dotted line is like this? Instead of this point, it is increasing little bit earlier. These are soil solids. I'm waiting for your comments, guys. I'm waiting for your comments. Everyone. Guys, because here when water is filled now, water is almost filled and might be only 4 small voids are there. Small voids are still there. Okay, but now there is no space of filling that void. So if you add more water, volume start increasing. Although there is some space left. So theoretically it should increase after it is completely saturated. After it is completely saturated, then volume will be start increasing, but 2-3 voids are blocked. So instead of water going there, it start volume increasing. Okay, that is why it is shown dotted. So more water than like this. If we increase the water, it is solid state, then it is semi-solid. Further increase the water, it will be plastic, and then it is liquid state. That is WL, liquid limit. Liquid limit means that water content above, after that soil behaves liquid. The shear strength is negligible, around 2.7 kilonewton per meter square. And 2.7 kilonewton per meter square is very less in compared to soil other values. So WL is that water content after which soil behaves as liquid. WP is that water content after which soil behaves as plastic. That means if you draw the stress strain curve here, then it will be like this, plastic, almost straight line like this. Okay. So there is a term called plasticity index, IP. IP is WL minus WP, this range. WL minus WP is this range where the soil is plastic. Generally clay has a higher plastic value. Okay, good Shubham, good, excellent. Okay, CU and CC in good question. Chandra, good question. Your question hurt me, it's paining here. Chandra, clay, well or poor का significance ही नहीं है. I told at the beginning that W and P gradation is more significant to coarse grain soil. Clay तुम well क्या कहोगे, poor क्या कहोगे? You said poor because all particles are same size, but still it is very strong due to cohesion. So दूर से देखा तो गंजे खेल रहे थे, पास जाके देखा तो अंडे उबल रहे थे. अभी सुनाई ना वाली कहानी. Okay, now how to find liquid limit? There is a Casagrande tool in which we with a particular water content we put the paste, then with a knife, Casagrande knife, we remove the soil with a 2 mm knife, then we like blow it, okay, like this, then it goes up, then hit back. We rotate it, it goes back, hit back. So after some time it joins. So we make a graph. Here I put log n, the number of blows for joining this, and here I put water content. This will be of course decreasing because more water content, less number of blows will be required. Less water content, it is solid, more number of blows are required. By plotting this graph and the value corresponding to 25 blows, whatever the water content is coming, that is the liquid limit corresponding to 25 blows. So this is the most common method of finding the liquid limit, although there are some IS cone penetration method and 1-point formula also. Okay, like this, this equation line is given. Can you tell me what is the slope of this line? What is the slope of this line? Can anybody tell me what is the slope of this line? Yes, my champions. Yes, my commandos. Anyone? Slope of this line? Yes, flow index. किसने बताया? Shubham. Samrat. This slope is flow index, IF. Okay, y2 minus y1, w1 minus w2 upon log n2 minus log n1. Okay. So this will be, slope is what here? If I represent magnitude. So suppose this is w1, this is w2. So w1 minus w2 upon log, this is n1, this is n2, log n2 minus n1. So log n2 minus n1 is n2 by n1. Now this kind of questions will be asked. So this is the equation of that blue line. This blue line, this is the equation. Find the liquid limit. So liquid limit is corresponding to 25 number of blows. Put n is equal to 25 here. So whatever value is coming, that will be liquid limit, 20 minus log 25. Okay. There is consistency index. So consistency index is WL, that is liquid limit, minus W, that is natural water content, whatever is the water content of the soil in existing condition, okay, upon WL minus WP, that is the IP value, and IC plus one more, liquidity index, is equal to 1. Consistency index plus liquidity index is equal to 1. Okay. So this IC plus IL is 1. Now you may first इसका क्या करेंगे? अचार डालना है? What we will do this from this, sir? Let me tell you. Suppose IC comes negative. Suppose someone reports, a geologist reports that for this particular site, IC is negative. IC negative means numerator negative, because denominator will always positive. Liquid limit will be greater than plastic limit. So numerator negative means this water content. That means the water content of soil is greater than liquid limit. That means soil is in almost liquid state there. I will say, we will make building there. If IC is very, very less, negative or around 0, that soil is very bad. That means water, either we have to de-water the soil or stabilize the soil. Otherwise, if we are not doing anything, that soil is bad. So IC negative means that soil daldali hogi. And as IC value is more, that means water content is less. That means it is a dry state of soil, like here. If IC is less than 0, soil is in liquid state. As IC value is more, so soil is more dry, and as it becomes dry, it becomes brittle, and reverse for IL. Reverse for IL. And guys, one more thing, that numerous objectives will be done from this statement, whatever I am doing this. Okay, Gyanji. Okay. Now see. ये सही करा रहा हूँ, चेक कर लो कुछ गड़बड़ तो नहीं है. ओके, शेयर करते रहना भाई वीडियो को, लाइक और शेयर करते रहना. सो मेनी स्टूडेंट्स, ओनली 30 लाइक. यार लाइक वाइक हिट करो. अच्छा, ऐसा कभी सोचा है कि लाइक टीचर क्यों हिट कराता है? ओके, टीचर लाइक क्यों करवाता है? Why? Guys, everyone wants that if he is preparing some content, taking the classes, more number of students watch this class. There's nothing wrong in that. And YouTube has an algorithm that if more number of likes are there, then it will promote more. Okay, simple funda. Okay, otherwise ऐसा नहीं है कि सब लाइक कह रहे तो आधे मतलब कुछ लोग तो कर रहे होंगे, सब लाइक बोल रहे तो हम भी बोलते थे लाइक करो. Okay. Now guys, one thing I want to tell you, from this numerous questions will be solved, that if liquid limit is more, guys, for that soil, void ratio will be more, voids will be more. More void, soil will be having more void. That means more water can be filled in this before it comes saturation state. That means more further water will be there for making it liquid. So more voids means more water will be there. More water, it will come up to only saturation, up to only shrinkage limit, then further more water up to liquid limit. So if liquid limit is more, means void is more. If void is more, that means more compressible. Settlement will be more. Compressibility will be more. Strength will be less. Like this. Now, Moving further, what is toughness index? IT is equal to IP by IF. IT is equal to IP by IF. Everybody knows this? Tell me fast. Tell me fast on the comment box. IT is equal to IP by IF. Okay, IP is plasticity index and IF is flow index. IP is plasticity index and IF is flow index. Any doubt? Vandana got it. Okay, moving further now. IT भी हो गया. चलो अब यहाँ से और आगे जाते हैं. This is DR, relative density, also called as ID, also called as RD. This is E max minus E upon E max minus E minimum. What is the theoretical maximum void ratio? Maximum void means it is in the loosest state. Maximum voids means it is in the loosest state. So E max is 0.91. And minimum void ratio means it is in denser state, it is 0.35. Okay, you can see my other videos of soil mechanics where I proved this and I have given the logic. Okay, why in loosest state the arrangement is cubical? Because to make maximum voids, the other layer we are putting just one over the other. I have proved this 0.91 value as well. Okay, if we are just putting over, that means we are not occupying the void, so maximum voids. So that is cubical array. Okay, now if we want to make minimum void ratio, minimum voids, so second layer will be putting here. Second layer will be putting here. Second layer will be putting here so that voids can be occupied. Okay, then next layer will be putting here so that voids will be occupied like this. That is Prince-Model error. Okay, and what is the significance? If void ratio is less, DR will be more. So more DR value, more relative density means void is less, void ratio is less. So it is densely packed. Okay, so this is more, that means it is very dense. Okay, because what is DR here? E max, that is a constant value, minus E upon E max minus E minimum. So if voids are less means it is more. If voids are less, that means it is more. More means very dense, like this. Okay, now if we, I'm not going in derivation, this can also be represented as DR. When voids are maximum, then density will be minimum. 1 by gamma D, this E means natural case. 1 by gamma D minimum minus 1 by gamma D max. And when E is minimum, that means density is max. You can directly prove this from here. That formula, gamma D is equal to G gamma W 1 plus E. From here find E. When E is max, this will be minimum. When E is minimum, this will be maximum. Find E, put here, you will get this. Give me yes or no everybody on the comment section. Give me yes or no everybody on the comment section, guys. Any doubt to anyone? Any doubt to anyone, guys? Tell me fast. Okay, moving further. Excellent. Okay, so DR value is there, guys. Now sensitivity is unconfined compressive strength of undisturbed soil. Okay, UCS of undisturbed soil. What is the unconfined compressive strength? What is unconfined compressive strength? In triaxial test we'll see. Suppose this is the soil sample and we are not confining it, we are not holding it, we are putting the load. That is unconfined compressive strength. Without confinement, at how much load there will be a shear failure. And unconfined compressive strength of remolded soil. Okay, so this is undisturbed and this is disturbed. Remolded means disturbed soil. So what is the ratio? That is sensitivity. If the ratio value is 1, that means without disturbance and with disturbance the value is same, that means insensitive soil. If the ratio is 1, that means the strength with undisturbed and disturbed, that means both are same, that means it is not sensitive. Okay, like this. Now one more thing, activity ratio. Activity ratio is, what is the activity ratio? That value is IP upon percentage of clay particles. IP upon this percentage of clay particles. Okay, एक खाली पेज दो, एक फॉर्मूला और आपका छूट गया था, that is, यहीं पे लिख दूं, shrinkage ratio. shrinkage ratio is V1 minus VD. Okay, guys, when we, this V1 means this case here. This is W. Okay, this is V. So it is like this, na? After shrinkage limit value increases. So this is VD, and somewhere here it is V1. This is shrinkage limit, and somewhere here the water content is W1. V1 minus VD with this change in volume with respect to the original volume, and this change in volume is how much water content from W1 minus WS. This is shrinkage ratio, and this shrinkage ratio comes to be gamma D by gamma W. Gamma D by gamma W. And what is volumetric shrinkage? What is volumetric shrinkage? It is V1 minus VD upon VD into 100. Okay, shall we move further? Any doubt till here? IP upon, yes, correct. Guys, speed is going, should be increased. No more number of formulas are here, guys. In CPA effective stress chapter, there is not much formula. Quicksand condition is a big chapter, but formula wise it is very small chapter. So in this chapter only there are a lot of formulas. In here, guys, classification of soil, there is no formula. No formula. On different cases, the values and names will be different. On different cases, values and names will be different. I recommend you all, guys, if on the YouTube, on the search option, you will write the soil classification in easiest way by Abhinav Negi, then you will be getting videos. See my conceptual videos, guys. There, if you see that video, then my friends, my champions, I've told everything, every logic. I challenge you guys. In no other video you will be finding the so much detailed description. Why the name is GW, why the name is GC, everything I discuss. Why above A line? Okay, there is a A line in plasticity chart. Can anybody tell me? Let me take your test. This is a IP and this is liquid limit. So this A line is, what is the equation of A line? IP is equal to 0.73 WL minus 20. So at WL value 20, IP will be 0. Now why above A line it is clay and below it is silt or organic? Can anybody tell me? Why above A line it is clay and below it is silt or organic? Okay, next question. 20, 35, 50. Why it is low here? Intermediate compressible here and it is high compressible here. This is silt or organic and above it is Cl, Ci, Ch. Two questions. Why above clay, below silt? And why there it is H, here it is I, here it is L? Can any one of you tell me? Can any one of you tell me, guys? Please tell me. Please tell me. Everyone. Every commando. Every chapan. बता दो. नहीं बताओगे? गुस्सा हो? Okay. Guys, the reason being above is clay because clay is more plastic. IP value will be more. And this is the Lakshman Rekha. So above that clay, because IP has more y-axis, more this IP value, more plastic. And why there H? I just told you, more is the liquid limit. This liquid limit. So more is the liquid limit, more is the void ratio. So it is high compressible. Therefore on right is H and it is L and between it is I. Okay. Now this is the A line. Now in compaction also, guys, what is compaction? What is compaction? Compaction is that when you apply the load on a partially saturated soil, then initially all air voids are removed. Theoretically, we are assuming that 100% air voids are removed. That is compaction. Okay, compaction is removal of air voids. Compaction is removal of air voids. Okay, and if sufficient energy is provided and all the air voids are removed, okay, then further load is coming. Then water will come in high pressure. Nobody wants to be in high pressure. It comes in excess pore water pressure. Nobody wants to be in excess pore water pressure. In that case, water starts dissipating and that is consolidation. That is time taking because speed of water is not like Usain Bolt. But compaction is very instantaneous phenomena. Generally for sand, we provide the vibration techniques. Okay. Now for sand, first of all, let me tell you, although this is a formula session, but still let me tell you, for sand what happens, if I make a gamma D and water content graph, the graph like this, at 4 to 5% water content, density is minimum. What happens in sand at 4 to 5%, honeycomb structure is formed. A honeycomb structure is formed where the bulging takes place. That means a negative pressure is generated and a chain is formed like this. A chain is sucked up and here it comes voids. So more voids means less density. So this negative pressure, this capillary action, this suction action is maximum at 4 to 5%. Guys, this capillary action is happening at every water content, but this is maximum at 4 to 5%. So maximum suction, maximum such voids are formed at 4 to 5%. Although in this chapter, the more important is cohesive soil. For cohesive soil, what is the condition? Let me tell you that if this is water content and if you provide here gamma D, then the graph is something like this. And at maximum water content, at the water content at which the gamma D is maximum, that is OMC, optimum moisture content. Why the graph is like this, I'll tell you. This is dry of optimum and this is a wet side of optimum. Guys, what happens here, that initially when you are adding the water to the soil, it is acting like a lubricant. Okay, so when you are applied the load, lubrication is decreasing the friction. That means easily it can be compacted. So initially when you are adding the water, what is happening? Actually lubricant is increasing. Lubricant is increasing means friction is decreasing. Friction is decreasing means if we apply the load, easily it can be compacted, and less is the volume, density will be increasing. I am again saying, as water content is increasing, that means lubricant is increasing. Lubricant is increasing, that means friction is decreasing. Friction is decreasing, that means if we apply the load, easily it can be compacted. Particles will not be resisting by applying friction. Easily it can be compacted. And when easily it can be compacted, less volume, so gamma will be maximum. After OMC, what happens? With further addition of water, there is so much water that a place where the solid can go and occupy in the denser position, that already water is present there. Because you have added so much water that जो lubrication से फायदा हो रहा था friction reduce करने का, वो इतना बड़ा फायदा नहीं है, जिससे ज्यादा मैग्नीट्यूड का ये नुकसान है कि वाटर वहां बैठ गया है, जहां पे इतना पानी डाल दिया कि water has been sit where the particles can go, and we are now studying consolidation, water will not go out. So after that process, gamma D decreases. Okay, there it is dispersed structure and here it is flocculating structure. Now guys, for cohesive soil, if I make a graph with even energy, it is like this. If I provide a greater energy, E2 is greater than E1, then guys, here the OMC will be lesser. OMC2 will be lesser than OMC1. The OMC2 value is lesser than the OMC1 value, although my big figure is not suggesting, but it's okay. This OMC1. So when greater is the energy, then less water content is required. Guys, to compact, one helping is the energy and another help is from the lubricant. So if one friend is increased, so other factor will be reduced. Okay, now there are the various values of the test. Okay, what is the Proctor test? We take a sample. Okay, and we are plotting a graph here also. Water content and gamma D. Okay, gamma D max, theoretically, gamma D max, that is 0 Edward line, is found from G gamma W upon 1 plus WG. Okay, of course, not going into the derivation. G gamma W upon 1 plus WG. 0 Edward line. Now, what is happening here? That we are taking a sample with a given volume and given weight. We put one layer of soil and then compact it from a what is the weight? 2.5 kg weight rammer, and this 2.5 kg rammer we are falling 25 times, 3 layers of not 2.5, 25 times and the height is how much? 305 mm, 0.305 meter. So we compact it 25 times. Then we put one more layer and compact it again 25 times with same weight and same height. Then again after that we put one more layer and again compact it 25 times. Then we take a sample and find the density, gamma d. 1 point is obtained. Then we repeat all this process by compacting 25 times in one layer, then second layer compacting 25 times with different water content. So different water content value will be different, different water content value will be different. So we repeat this test and we get this curve. From here we can get OMC. So we get the water content at which a soil should be compacted to make it maximum dense. Now if we find the energy per unit volume, what is energy? mgh. Mass, g is 9.81, height is this, and how many times? 75, 3 into 25 upon volume 944. This value comes to be instant 594.29 kilojoule per meter cube. 594.29 kilojoule per meter cube. What we have done? We have dropped this weight 25 times. Okay. Then again second layer 25 times. So what is the energy? mgh. So m g 9.81 into h into 75 times divided by volume. This value is this. So there are some different tests also. बस नाम बदल दिया, इंडिया वालों ने थोड़ा सा नाम बदल दिया, डायमीटर चेंज कर दिया. So here this 4.54 kg from 457.2 944 cc is the volume. Here the same energy per unit volume, here it comes to be 2696.3 kilojoule per meter cube. That is 4.5 times of the earlier test. So these values are been come in gate examination. Okay. Similarly, one more Indian standard light compaction test, weight 2.6, 310 mm, volume this. Here also the compactive effort per unit volume is m g 9.81 into h into 3 layers of 25 blows, and this value comes to be 593.014 kilojoule per meter cube. Now Indian heavy compaction test, again the values are given. Okay, again here if you find here compactive effort per unit volume, so here you will be getting the value as 2703.88 kilojoule per meter cube. Give me yes or no, everyone. Everybody on the comment section, have you got it? Have you got it? नहीं हो रहा क्या भाई? मैं स्टार्ट नहीं हो रहा क्या? क्या लिखा है? Looks like diesel is back. Okay, the cutoff time of 20 inches is this. Looks like it is a good practice for Indian batters and also for the Pakistan bowlers. भगवान भी ये चाहते हैं कि तुम सॉइल पढ़ो. ओके, भगवान भी चाहते हैं सॉइल पढ़ो, इसलिए बारिश हो रही है लग रहा है. वो तो आज बचा लिया थोड़ा बहुत ईशान किशन और पांड्या ने, नहीं तो पूरा बेइज्जती खराब होने वाली थी आज तो. सही बोल रहा हूं? सही बोल रहा हूं भाई? करेक्ट? बोल दो यार. नहीं बोल रहे. चलें आगे? चलें? भाई कोई इज्जत है टीचर की कि नहीं है? चलो देखो हमारा कौन कौन चैप्टर हो गए भाई. ये हो गया, ये हो गया, तो ये से कॉम्पैक्शन हो गया. इफेक्टिव स्ट्रेस इनमें कोई ज़्यादा चैप्टर है ही नहीं, ज़्यादा फॉर्मूले है ही नहीं. अच्छा, वर्टिकल स्ट्रेस वाले का मैं आपको अलग से नोट्स में दे दूंगा. इसका मैं यहाँ इस वाले में नहीं कराऊंगा, इसका मैं अलग से आपको नोट्स दे दूंगा. इसमें बहुत सारे एम्पेरिकल फॉर्मूला है, कोई तो डेरिवेबल है नहीं. ओके, इफेक्टिव स्ट्रेस में एक ही फॉर्मूला है, सिग्मा बार इफेक्टिव स्ट्रेस इज टोटल स्ट्रेस माइनस पोर वाटर प्रेशर. What effective stress represents? What effective stress represents? If more is the effective stress, that means there is more contact pressure between the particles. If more is the effective stress, then it means that there is more contact pressure between the particles. Okay, and effective stress more is good. Effective stress is more, it means it is good. Okay, it's good. It's good. Okay, effective stress is less, it is bad for us. Reason being, if the contact pressure is less, if the contact pressure between the soil is less, that means it can easily shear failure. If contact pressure is less, from two particles, if the contact is not much, it is less, so easily it can be shear failure. Now what happens in rainy season? In rainy season what happens? Why there are more landslides? In rainy season why there is landslides? Why there is more landslides? Because pore water pressure increases. Water table increases, so water table increases, so pore water pressure increases, so pore water pressure increases, sigma bar decreases. So if sigma bar decrease, that means the contact pressure is less and easily it can have a shear failure. Guys, you are not commenting here. I don't know what happened. Everybody यार, come on, कुछ तो एक बार हर्ट वर्ड, कुछ तो A B C D कुछ तो लिखो भाई. कि एकदम सब मोबाइल लेके बस यही कर रहे हैं कि हम पूरा उतार ही लेते हैं आज. कुछ तो लिखो भाई. एवरीवन. ओके, तो परमिबिलिटी इफेक्टिव स्ट्रेस में और ऐसा कोई फॉर्मूला नहीं है. हाँ, आपको कैपिलरी का, अगर आपको कैपिलरी का फॉर्मूला देखना है, कुछ एम्पेरिकल फॉर्मूले होते हैं कैपिलरी कितना राइज हुआ. एक तो नॉर्मल आपके पास फॉर्मूला है ही कैपिलरी राइज का. ओके फारूक साहब, एक तो नॉर्मल कैपिलरी राइज का आपके पास फॉर्मूला है ही, गामा डब्ल्यू इंटू डी वाला, है ना. कितना है एक बार मैं देख लेता हूँ. एच एक तो नॉर्मल फॉर्मूला है ना कैपिलरी का. ये एच इज इक्वल टू कितना था, एच इज इक्वल टू डिराइव में कर सकता हूँ, मेरे को याद नहीं है, लेकिन मैं डिराइव कर सकता हूँ उसको, पर याद नहीं है भाई. डिराइव कर दूंगा अभी. पाई डी स्क्वायर बाई 4 इंटू एच इंटू वॉल्यूम और ऊपर सरफेस टेंशन का. तो जो एक तो नॉर्मल फॉर्मूला होता है कैपिलरी राइज का, कैपिलरी राइज का जो डिराइव करते हैं हम, वहां से जो कैपिलरी राइज आता है वो आपके पास आता है 4 सिग्मा कॉस थीटा. एक लाइन का इक्वेशन है. ओके, ऊपर जो सरफेस टेंशन का फोर्स आएगा सिग्मा इंटू पाई डी इंटू कॉस थीटा, और नीचे पाई डी स्क्वायर बाय 4 इंटू एच. 4 सिग्मा इंटू कॉस थीटा upon gamma w into d. D is the diameter of capillary tube. If the occasionally means capillary tube is less, then more rise it will be. There are certain empirical formulas also, okay, that students sometimes miss. Okay, what are those empirical formulas for finding out the capillary? Is one is H is equal to 0.03 upon D in mm. Okay, this D is the diameter of tube. Okay, and H is capillary rise in meter. H is capillary rise in meter. Now one more formula, H is equal to capillary rise. All these are empirical, guys. 0.03 into 0.2 into D10. Of course, D10 is the effective size. Diameter below which 10% particles are finer. Here D10 is the effective size in mm. Okay, and H you will get from here. There is one more. These formula sometimes comes in the examination. One more formula for capillary rise in centimeter, and this is formula is C upon E into D10. Okay, this is C upon E into D10. D10 is effective size, E is the void ratio, C is a constant, and C value is 0.1 to 0.5. 0.1 से लेके आपके पास ये वैल्यू होती है 0.5 सेंटीमीटर स्क्वायर तक. Okay, this is the derivable formula. Okay, and these all three are the empirical formulas, and these two are the capillary rise in soil, and this is the capillary rise in a tube which is put in the water. Now the permeability of the soil, of course the Darcy law says that V is proportional to the hydraulic gradient. Hydraulic gradient is HL by L, head loss per unit length. All the loss occurs in the soil. In water there is no loss. So this is removed by, proportional sign is removed by K. K is permeability or hydraulic conductivity. Okay, people think that K is the speed. No. K is not the speed of water. Yes, if K is more, speed of water is more. This is the speed. If K is more, speed is more. If K is less, speed is less. But K exactly is not the speed. Even actually this is also not the speed. Actual speed Vs, this is the discharge velocity. This is the discharge velocity. Actual velocity, which is true velocity or seepage velocity, is given by, not going in derivation, V by N. N is porosity. So N is less than 1. N is always less than 1. Porosity, volume of void by total volume. So that means seepage velocity is always greater than the discharge velocity. What is the difference between discharge and seepage velocity? Now, discharge velocity is, you are saying that it is discharged by area of soil. Okay, so from here there is water, water going here. From high head to low head, water is going here like this. So here in discharge velocity you say discharge by area, but actually the real velocity, the seepage velocity or true velocity, is discharged by area voids, because the from total area the water is not coming. Water is only coming through voids. Okay, so this is the seepage velocity. And as V is equal to Ki, similarly Vs is equal to Kp by I. This K is hydraulic conductivity or permeability, this Kp is coefficient of percolation. And from here, V by Vs is equal to N. V by Vs is equal to K by Kp is equal to N. Everyone, please let me know, have you understood this? Shubham, now you got it? Shubham, now you got it, the difference? Shubham, now you got the difference? Please tell me. Please tell me. Okay, now the equivalent permeability when the flow is parallel to the bedding plane is K1 H1 plus K2 S2 plus K3 S3. If H1 thickness has permeability K1, S2 thickness has permeability K2, S3 thickness has permeability K3. When flow is parallel to the bedding plane, in that case, the equivalent permeability K equivalent, or also called as KH, is K1 H1 plus K2 S2 plus K3 S3 upon H1 plus S2 plus S3. When it is perpendicular, water is going perpendicular. In perpendicular, guys, discharge is same. For every layer, discharge is same. Okay, this discharge is same. Whatever I am saying now, that is used while applying the equations in the exam. So here the K vertical or K this is H1 plus S2 plus S3 plus H4. Let the total height be H. Okay, you can also write this as H1 plus H2 plus S3 plus H4 plus Hn upon this. As you see here, it represents arithmetic mean. This is arithmetic mean, guys. K1 plus K1 plus K1 H1 times plus K2 plus K2 plus K2 plus K2 S2 times. So like this. And total number how many times? H1 plus S2 like this. This is the arithmetic mean, this is the harmonic mean. Of course, arithmetic mean is greater than equal to, geometric mean is greater than equal to harmonic mean. So of course, the K parallel to the bedding plane is greater than K perpendicular to the bedding plane. Okay. K equivalent, when Kx and Ky are different, is under root Kx into Ky. Now this is the Cozen-Kármán equation. For permeability, it is 1 by Kk is the constant, gamma W by mu into Eq upon 1 plus mu into D10 square. D10 is the effective size. Now here various questions I have, like temperature increases na, so mu decreases. For liquid, for gas mu increases, but for liquid mu decreases. So mu decreases means K increases. That means with increase in temperature, K increases. Now my question to all of you. Now my question to all of you guys. Now my question to all of you, that my friends, my commandos, my champions, everyone out there, temperature increases, mu decreases and K increases. Okay sir, got it sir. And from here it seems that K is proportional to E cube upon 1 plus E. That means if void is increasing, K will be increasing. If void ratio is increasing, K is increasing. If void ratio is increasing, K is increasing, although it is cube, here it is 1 power, it is cube 3 power. So void ratio increasing, K is increasing. Now my question is, for K for fine grain soil is less than K for coarse grain soil. Permeability of coarse grain soil is more, but void ratio of fine grain soil is greater. Void ratio of fine grain soil is greater than coarse grain soil. So if void ratio is more, then K should be more. So even with fine grain soil has bigger void ratio, why permeability is lesser? Can anybody tell me? Can anybody tell me this? Even with void ratio is bigger, why the permeability is less? Why the permeability is less? I want to know the answers. I want to know the answers. I want to know the answers. Can anybody tell me this? No? Okay guys, this formula is for same size of soil, whose if we are comparing coarse and coarse, if we are comparing coarse and coarse soil, then whose void ratio will be more, will be having more permeability. We are not comparing the two different soils with different diameters. Then D10 will also come in the picture, na? Then D10 will also come in the picture, na? So we are only denoting K on the base of E. That means we are removing this D size. Got it, everyone? Everyone got it, guys? Everyone got it, guys? Please let me know. Okay. So this is for same size of soil. Now let us go to the consolidation. Guys, vertical stress, I'll provide you the notes, not taking here, because every formula there is empirical. Either the Newmark chart, Boysengy, Westergaard, all of them. Now the total settlement of a soil is C. Everyone. The total settlement of a soil is SI, that is immediate, plus S1 degree plus S2 degree. Now what is immediate settlement? Suppose the soil is like this, solid, water, air. I apply the load. Initially what happens? Compaction take place. So air voids will be removed. So this is immediate settlement. Immediate settlement. S compaction. This is the compaction settlement. Okay, this is instantaneous. Very fast. Then if the load is further there, then water will, in a saturated soil, all load is initially taken by the water. So water comes in excess pore water pressure. Nobody wants to be in excess pore water pressure. So water decreases. So this is called as S primary consolidation, SC or S1 degree. Consolidation by default means primary consolidation. Okay. So SC or S1 degree. So water is decreased here. Water is decreased here. Okay. This is, and in consolidation chapter, this is important. By default, consolidation means 1 degree consolidation. By default, the consolidation means 1 degree consolidation. That means primary consolidation. Okay, water is removed. Then further after some time, the particles rearrangement takes place. Highly viscous water, which was initially not coming out, not dissipating out. Here the water comes in excess pore water pressure, it starts dissipating. So if highly viscous water, which was not coming out, or some plastic rearrangement of particle take place and further settlement is there, very less, after a very long amount of time, that is secondary consolidation. In consolidation chapter, every formula, everything is for here. Okay, this is for compaction. S immediate is this, Q into B. Q is the pressure intensity, B is the width of foundation, mu is the Poisson ratio, IF is the influence factor, ES is the Young's modulus of elasticity. This is immediate settlement. Similarly, the formula for secondary consolidation is there, not required for us. Okay, and for immediate settlement, what is this, what is the formula, let me tell you. Before that, let me tell you guys that change in volume with respect to original volume is change in height with respect to original height. The reason being very simple, because every time in SOM you study any chapter, it is written that material is homogeneous and isotropic. Similarly in soil it is written, that material is semi-infinite. Always in soil you measure the depth of clay, you measure the depth of sand, you measure the depth of gravels, you measure that at what depth water table you are getting, but you never measure that clay is 3 meter out how much area, water table is 4 meter below after how much area. You never studied this. So in lateral direction, in area direction, soil is considered to be infinite. Every change is in depth. Vertical movement of water is considered, not the lateral movement. Every change is in the depth, not here, not horizontally, not laterally. So whatever is the change in volume with respect to original volume, volume is area into height, na? Volume is area into height. So area is not changing. So whatever is the delta V is, that is equivalent to delta H. Okay, will delta H not, because area is not changing. Okay, now total volume is Vs plus voids, volume of solid plus volume of air plus volume of water. Volume of air plus volume of water I can write as volume of voids. So Vt is equal to volume of voids I can written as E into Vs. So total volume is Vs into 1 plus E, or E naught initial void ratio. After some time Vt is Vs into 1 plus EF final void ratio. So what is delta V? This minus this, initial volume minus this. So Vs into 1 plus E naught minus Vs 1 plus E into F upon original volume Vs into 1 plus E naught. Vs cancelled, 1 cancelled. So E naught minus EF is delta E, and denominator is 1 plus E naught. Got the understanding of this formula? Have you got the understanding of this formula? Please tell me. Please tell me. Okay. Now there is a term, overlay consolidation ratio, OCR value, that is maximum stress in history upon the present stress on the soil. For NCC soil are those soil where the today's stress is the maximum stress. So denominator is the maximum. So OCR is less than or equal to 1. NCC soil means that today's stress, whatever coming today, is the maximum. Okay. And OCC soil means here the today's stress is very less. Past में बहुत ज़्यादा लग चुका था, आज का बहुत कम है, न्यूमरेटर ज़्यादा है, तो OCR greater than 1. Guys, of course the settlement of NCC soil will be more. Of course the settlement of NCC soil will be more. Okay. The reason being that in NCC soil, earlier the stress was not much, today's stress is much, so large amount of settlement can take place. In OCC soil, the earlier stresses were maximum, today's stress is very less. So पहले उसमें बहुत ज़्यादा लग चुका था, सेटलमेंट हो चुकी है, आज का तुम थोड़ा सा लगा के क्या कर लोगे? तो NCC soil will be having a larger settlement. Got it? Everyone? Please tell me. The match has been called off, guys. The recent update, India versus Pakistan, Asia Cup. पता नहीं क्यों श्रीलंका में रखते हैं, मेरे को समझ नहीं आया. श्रीलंका में मैच रखने का मेरे को नहीं पता कि श्रीलंका से ज़्यादा कोई और ऐसा देश है जहाँ बारिश होती है. अब 12 महीने बारिश होती है, मतलब वेस्ट इंडीज़ में भी उतनी नहीं होती है, वेस्ट इंडीज में बहुत बारिश होती है. श्रीलंका मैच कराना ही नहीं चाहिए, एक तो वहाँ की. ओके चलो, मतलब होती है बारिश, इंडिया में भी होती है, साउथ अफ्रीका में भी होती है बारिश, इंग्लैंड में भी होती है, इंग्लैंड में भी अच्छी खासी होती है, वेस्ट इंडीज़ में होती है ना. बारिश मैंने एक जगह नहीं देखी. कोई गैस करेगा कौन से देश में आपने कभी, मतलब इंग्लैंड में बहुत देखा होगा बारिश से मैच नहीं हो रहा, ऑस्ट्रेलिया में भी कभी कभी होता है, वेस्ट इंडीज़ में भी बहुत ज़्यादा होता है, श्रीलंका तो खैर अलग ही लेवल पर है ना. पाकिस्तान में बहुत कम होता है, बहुत कम. एक और जगह जहाँ आपने बहुत रेयर देखा होगा बारिश, साउथ अफ्रीका में होता है जिम्बाब्वे। जिम्बाब्वे में आपने नहीं सुना होगा कि बारिश की वजह से कभी मैच एकदम बढ़िया, जब भी मैच देखो क्लाउड भी नहीं आते, बढ़िया एकदम धूप से, एकदम चमचमाती धूप से एकदम बढ़िया लग रहा होता है एकदम मैच, क्योंकि इक्वेटर के पास है ना, वहां पे मैंने कभी नहीं देखा कि बारिश चल रही है। मैच भी खैर वहां पे कम होते हैं। ओके। और न्यूजीलैंड में या तो वैसी वाली बारिश होती है कि उनका स्टेडियम वेडियम पूरा ही टूट जाता है, ऐसे ड्रिजल नहीं देखी कभी। ड्रिजल ये सब कॉन्टिनेंट में ही ज्यादा होती है। इंडिया वर्सेस पाक एशिया कप कॉल्ड ऑफ, एबेंडेंट है ना। चलो आगे चलते हैं। कोफिशिएंट ऑफ कंप्रेसिबिलिटी क्या होता है? दैट इफ वी मेक अ ग्राफ ऑफ डेल्टा ई or not delta E, if we make a graph of E and sigma bar, then more is the stress, lesser is the void ratio. If more stress you apply, the void ratio will be lesser. So this will be like this. This curve will be like this. Okay. Now for E1 void ratio, stress is suppose sigma bar 1, or E2 stress is sigma 2 bar. The slope of this line is called coefficient of compressibility. So y2 minus y1, that is delta E, upon x2 minus x1, that is delta sigma. Generally we represent minus here because delta is negative value, no? Final minus initial is negative, final void ratio is lesser. So to make it positive, we put one more minus sign. Coefficient of compression, CC. Okay, so if I make a E and log sigma bar graph for NCC soil, then it becomes almost a straight line. Okay, it becomes almost a straight line. For E1 void ratio, effective stress is log sigma 1 bar, and for E2, when effective stress is increased, log sigma 2 bar, it is E2. Now slope of this line is coefficient of compression. Slope of this line is coefficient of compression. Okay, that is slope is y2 minus y1, that is minus delta E upon log x2 minus x1, log sigma 2 bar minus sigma 1 bar, that is log sigma 2 bar by sigma 1 bar. This is also sometimes written as like this, minus delta E log sigma naught bar upon sigma naught bar plus delta sigma, anything here. I can write two numbers as x and y, or I can write two numbers as x, and y I can write as x plus something, x plus alpha. Okay. So CC is more widely used than AV. The reason being very simple, that CC is a slope of a straight line, and slope of a straight line is always constant. Slope of a straight line is always constant. Okay, so we use more CC. Now CC has some empirical formulas also. CC has some, either you find it from this graph, either you find the values of CC from these graph, otherwise there are some empirical formulas. Let me check whether it is written in my copy or not. Okay, that yes, for it is for mediums to low sensitivity, it is 0.009. And this empirical, guys, nobody can do this. Okay, this is most widely used. Okay, for it is medium to low sensitivity. For remolded clays, CC value is 0.007, WL minus 7, liquid limit minus 7. Okay, and CC is equal to 1.15, E0 minus 0.35. So these are some empirical relations also. Okay. Now coefficient of recompression, guys, for OCC soils, even I make a log graph paper, then also it is not straight line, it is still like this. OCC soil, remember, in OCC soil in past the stress was already been there, maximum stress has already been there. Okay, in OCC soil. So today with stress is not much. So today's stress is not much, that means today's stress is not much, that means settlement will not be more. That is why the curve is flat. It is not coming downwards like NC soil. And slope of this is CR, coefficient of decompression. That is 1/5 to 1/10 of CC. It is flat, so slope will be lesser. It is flat, so slope will be lesser. Now the settlement. This, guys, settlement means by default in this chapter, the settlements means primary consolidation. Okay. So here, guys, the consolidation settlement delta H is delta E upon 1 plus E naught into H naught. One formula is this. Any of these formulas can be applied depending upon what values are given. MV is AV upon 1 plus E naught. Coefficient of volume compressibility is AV upon 1 plus E naught. MV formula is definition is change in volume with respect to original volume with change in effective stress. With change in effective stress, how much change is occurring in volume? Okay, so delta V by V naught is delta E upon 1 plus E naught into delta sigma bar, and delta E by delta sigma bar was AV. So MV is equal to AV upon 1 plus E naught. So these are the formulas for finding out the settlement. MV delta sigma bar into H naught, L delta H, this is mostly used formula. CC H naught upon 1 plus E naught log sigma 2 bar by sigma 1. Okay, now what is here? Delta E is change in void ratio, original void ratio, H naught is the thickness of layer for which I am finding settlement. Similarly, MV is coefficient of volume compressibility, delta sigma bar is change in effective stress, H naught is the thickness of that layer for which we are finding settlement. Okay, H naught is the thickness of layer for which we are finding settlement. CC 1 plus E naught. If the soil is NCC, we will use CC. If the soil is OCC, we will use CR, log sigma 2 bar by sigma 1. Now this delta sigma bar, if the soil is like this now, and we want settlement of this layer, suppose there is a building and the extra stress is P. So delta sigma bar is P by A, but P by A here will be different, A here will be different, A here will be different. So where I will be taking A, so that should be calculated at the center of that layer. For the layer for which the layer we are finding the settlement, the delta sigma bar, the effective stress, the initial effective stress, all these values should be calculated at the center of that layer. Give me yes or no? Yes, yes, unique. Give me yes or no? Everyone? एवरीवन बता दो भाई, आ रहा है समझ में? बता दो भाई. कोई दिक्कत तो नहीं हो रही है? ओके, हेलो हेलो कतियार सर, कैसे हैं? गाइस सी, one of our old student, my old student, right now the sir has done his MBA from IIM Kozhikode, is here to motivate all of us. Everyone, guys, please put a heart sign for my ex-student, okay? He has now completed his MBA also from IIM Kozhikode. Okay. Welcome, sir. Welcome. Now, let us go further, guys. TV is equal to CV into T by D square. Now, what is CV? CV is coefficient of consolidation that depends on only soil. That depends on soil, means for clay, CV will be something for a particular site. For a sand, CV will be something for a particular site. CV will be same. Now, TV is a constant that depends on degree of consolidation. Degree of consolidation is represented by capital U. Now, what is capital U? What is degree of consolidation? Suppose a soil has to be settled by 10 centimeter, total settlement 10 centimeter. Total settlement 10 centimeter. and consolidation takes place 3 years, 4 years, even primary consolidation also it takes 3 years, 4 years, 5 years, like this. Suppose till now the settlement is around 5 centimeter and total it has to be 10 centimeter. Total it has to be 10 centimeter and till now it is 5 centimeter. So how much is the degree of consolidation? How much is the degree of consolidation? 50%. So total it has to be 10 centimeter settlement and till now 4 centimeter has been done. So 40% consolidation has occurred. If total settlement has to be 10 centimeter and till at any after 7 months, after 2 years, 8 centimeter has been done. 8 meter settlement has been done. So it is 80% consolidation. Okay. If total settlement has to be 10 centimeter and till at any stage 9 centimeter has been done, so it means 90% consolidation has been done. So U represents degree of consolidation, that how much of total settlement, how much has been occurred, 70%, 80%, 90%. So for less than 60% consolidation, TV is calculated from here. Suppose 50% consolidation. So TV is pi by 4 into 0.5 square. Suppose 40% consolidation. So TV is pi by 4 into 0.4 square. Suppose it is 80% consolidation, more than 60. So TV is from this, putting U is equal to 80 here, 100 minus 80. So TV, it depends on degree of consolidation. For 20% consolidation of sand, for 20% consolidation of silt, for 20% consolidation of clay, TV will be same, because TV is nothing to do with soil. TV dip is a function of U. For 20% consolidation of sand, gravel, silt, clay, TV will be same, because for everything you will be putting U is equal to 0.2 here. So CV depends on soil and TV depends on consolidation. D is the drainage path. Suppose in a soil with H thickness, here there is rock and all the water is dissipating only upward. So it is single drainage. D is equal to H. Suppose the soil layer of H thickness and the here is sand, that means water can go. It is not impervious, it is pervious strata. Here also it is pervious strata, so water can go up or down both. Water will not go like this. That is assumption. In Terzaghi, it is assumption that water is only going vertical. Okay, literally it is not going. So half of the water going here and half of the water going here. So here in double drainage, D is equal to H by 2. Okay. Now D you understood. For single drainage it will be H. For double drainage it is H by 2. CV understood. Depends on soil. TV understood. T is the time for consolidation. Suppose you are writing this TV for 40% consolidation, pi by 4 into 0.4 square, then this time is corresponding to the completion of 40% consolidation. Suppose TV you are writing for 80% consolidation, by putting value here 80, that means this time that will be coming for 80% consolidation. Okay, and if the formula is single drainage and double drainage, if the soil is same, thickness is same, degree of consolidation is same, for 30% consolidation here and for 30% consolidation here, for same soil, same thickness, in double drainage time will be 4 times less. If you put this formula for single drainage and again put the formula for double drainage, everything will be cancelled, but only here it will be H and here it will be H by 2. So time will be 4 times different. In double drainage, time will be 4 times less, but total settlement will be same. Guys, ultimate settlement, that is total settlement, will be same. It has nothing to do with single drainage or double drainage. Suppose in this bottle there is half liter of water. Okay, suppose in this bottle half liter of water is there. So if I put one hole, yes Akash sir, if I put one hole here, then half liter will go down. If I put 2 holes here, if I put 2 holes, then also half liter will go down. By putting 2 holes, this will go faster, but total half liter will go यार. So, अगर तुम एक छेद करो तब भी आधा लीटर पानी बाहर जाएगा, अगर इसमें आधा लीटर है तो, अगर तुम 2 छेद करो तब भी इसमें आधा लीटर पानी बाहर जाएगा. 2 छेद में जल्दी जाएगा, लेकिन टोटल आधा लीटर पानी बाहर जाएगा, एक छेद में भी 2 छेद में भी. गिव मी यस और नो एवरीबॉडी, एवरीबॉडी, ब्रिक मंडो, ब्रिचम्पिन. कोई दिक्कत? कोई दिक्कत? Okay, so this is now this K permeability, CV I told you, gamma W MV. This is one more formula. Okay, now shear strength. Soil fails in shear strength, and shear strength is provided by 2 things: cohesion, interaction between the particles, either due to the cohesion due to charge, electrostatic attraction, which is in clay, or due to negative pressure. Negative pressure means suction, then also there is cohesion. And one shear strength is provided of friction angle phi. A friction angle phi is also gained by two things: by the friction between the two particles of soil, or by interlocking. If the particle 1 is like this and particle 2 is like this, then वो उसे खांचे में बैठ जाएगा. So there is interlocking. Okay. Now all the soil that you have seen, many videos, all of them are failure is in shear. All of the soils are failed in shear, guys. Okay, all landslides and all. Every time a huge soil mass is failed from there, guys. Okay. Okay, guys. Yes. Everybody keep sharing the session, guys, so that more and more students can join in. Now, guys, the shear strength is given by of a soil by C plus sigma tan phi. C is the cohesion, sigma is the vertical stress on the layer at which we are finding the shear strength. Shear strength at different layers of soil will be different. So whatever layer we want to find the shear strength, the sigma should be on that layer, and tan phi. And when we are using the effective stress parameters, then we call it is C dash and phi dash. Guys, see, C and phi are not inherent properties of soil. For the same soil, C and phi can be different. For the same soil, C and phi can be different. It depends on the type of testing, type of conditions. We generally provide, C and phi are not constant, guys. If you suppose in your backyard there is a garden, and from that garden you take a soil sample, and for that soil sample you are finding C and phi. So for you are finding C and phi, I will be finding C and phi, some other company is finding C and phi. It can be different depending upon the types of testing. So we should be providing the type of testing same as the field conditions, so that we can simulate our results with the actual condition. Like if actual condition is clay, that is very less permeability, that is undrained condition. So while finding C and phi in the sample, we should provide undrained conditions there. Okay, so we should be doing it like this. So simulating the field conditions, so that C and phi should be coming according to the field. Okay, yes or no? Everybody got it? Okay, so if while testing we are working on effective stress, then we get C dash and phi dash. Okay, everybody got it? Now moving further from here. Okay, now what we do now, that we take a sample, we put that sample in triaxial test, and everywhere there is water. Okay, sometimes there is water, everywhere there is water. So that water is applying the sigma 3 here, confining pressure, sigma 3 also called as sigma c from all around, sigma 3. Okay, that sample is like this, and I am applying the load like this, sigma 3 from all, from here, everywhere we are providing the sigma 3. Got it? Friends? Any doubt? No doubt. Good. So now to break this, we apply Davidic stress from here. Now to Davidic stress is only in vertical direction to break this sample. Okay, why breaking this sample? Because we want to find the C phi. So now what happens? Sigma 3 is coming from here, and from vertical direction it is sigma 3 plus sigma d. Sigma d is Davidic stress. Total it is sigma 1. Sigma 1 is bigger, so it is major principal stress. Sigma 3 is minor, it is minor principal stress, and due to this soil may fail. If we apply significant amount of sigma d, it will fail. Now if we draw the Mohr circle, this is sigma and this tau. What is the strength? That is also called Mohr failure envelope. Tau is equal to C plus sigma tan phi. So this is, if we are drawing this is y is equal to C plus this is x, sigma is x, m. This is the equation of straight line. Y, that is tau x, is mx plus c. So this is a straight line. Now, if this is the strength, more failure envelope. This is the strength, more failure envelope. Okay. This is the strength. Blue one is the strength. Okay. And at x is equal to 0. X is equal to 0. The value of y is c. At x is equal to 0, the value of y is c. And this is phi. This is phi. Now, guys, the two principal stress are sigma 1 and sigma 3. So this is sigma 1, sorry, sigma 3. This is sigma 3, and I apply little Davidic stress, very small Davidic stress. So it will be sigma 1. So this is yellow one is stress and that is strength. So no failure. No failure. If I apply little sigma d, little sigma d, little sigma d, no failure. If I apply a more sigma d, like this, again no failure because stress is less and strength is more. More sigma d, no failure. At one time when strength and stress are same, there will be a failure. There will be a failure. Suppose we take a sample, we take one experiment, we got this. This is the time of failure when it is failing. Again we take different sigma 3, we get different sigma 1 failure. We draw the common tangent, and that common tangent, this is C and this is phi. This is how we got C and phi. Now if these stresses are sigma, sigma, sigma total stress, then these are C and phi. If these stresses are effective stress, then these will be C dash and phi dash. And the okay, let me delete this. And the variation of, if this is the soil sample, in the soil sample here it is sigma 3, and to fail it, here we are applying sigma 3 is already occurring, sigma d also, so it is total sigma 1. So the relation between them is like this. Okay, now shear strength is C plus sigma tan phi na, but for clay phi is 0, so tau is equal to C for clay, and for sand C is 0, so it is sigma tan phi. This is for sand, and also NCC clay also it is same, but NCC clay also behaves as a sand. NCC clay also behaves as a sand. Okay. Yes, what if the soil is reacting in different nature? Most of the time it is shear failure, one wedge fails with another, but otherwise in some other cases it can be very rarest chance that the compression failure can be there. Okay, I just saw the message. Okay, now this is the relation between sigma 1 and sigma 3. Let me tell you guys, this 1 plus sin phi, 1 minus sin phi term na, 1 plus sin phi, 1 minus sin phi term, this is also called as Ka, okay, and this is also equal to tan square 45 plus phi by 2. This many of you knows, but many of you does not know that this is equal to cot square 45 minus phi by 2 also, because tan theta is cot 90 minus theta. So 90 minus this is 90 minus 45 is 45, and this minus will be like this. Okay, so this you can write as tan square 45 plus phi by 2 also. This you can write as cot square 45 minus phi by 2 also. This root also can be done like this. Similarly, 1 minus sin phi, 1 plus sin phi, this is Kp. This is equal to Ka, or this is equal to tan square 45 minus phi by 2, or it is cot square 45 plus phi by 2, like this. This is the relationship between sigma 1 and sigma 3. Why C and phi are 0? In clay, phi is 0 because clay shape is flaky. Flaky means the two surfaces are smooth, so there is not friction between them. In sand, why C is 0? Because C, the electrostatic attraction, C has the charge separation, clay has a charge separation. Sand has not neutral, no charge separation, so there is no cohesion there. Okay. Okay. Everybody got it. Any doubt to anyone? No doubt. Excellent. Okay, so this is the relationship between sigma 1 and sigma 3. Now guys, we have various tests, but direct shear box test, triaxial test, all these tests are in the field. All these tests, sorry, are in the lab. But guys, if a soil is very sensitive, that means the properties are changed very drastically. And when the properties are changed very drastically, that means if we take the sample from the field, then we make the sample for the triaxial test, then C and phi are not inherent properties. Then we are not getting the actual C and phi that are behaving in the field. We are getting some different CFI, because C5 is not the fixed property as I just told you. Okay, so in that case, guys, what we have two options. Either you have to take a undisturbed sample, void ratio should not be changing. Either you have to take a undisturbed sample, or you have to do the testing in the field itself. So either of these things has to be done. Okay, so one such case is vein shear test, which is done for sensitive soils like soft clay. What we do here, we insert this type of vein in the ground level and we apply the torque. Okay, these are the blades, length L and diameter D. When this will rotate, it will make this kind of area. When this will rotate like this, it will make this kind of area. So length L, diameter D. T is noted at how much torque it starts rotating, because of course soil will be resisting, at how much torque it starts rotating. And for T value and D and H we know, we can find the shear strength. Shear strength is, guys, this of course not going in the derivation. This is when top and bottom are both below. Okay, and this is when bottom of the vein takes, okay, this is when it is like this, when top part is above the ground level. Okay, now moving further, unconfined compressive strength test means unconfined. Okay, earlier what you are doing, you are confining the soil sigma 3 from all together, and then you are applying sigma D to break it. Okay, now it is unconfined, there is no sigma 3. You can see sigma 3 is 0 here. Without any sigma 3, at what load it is failing, that is the unconfined compressive strength. At how much compression it is failing, of course the failure will be shear failure. Okay, so sigma 3 is 0. And this is done only for clays. Only for clays. Why? Because sand will not be, without confinement, sand cannot be erect like this. Clay, due to cohesion, will be erecting like this without confinement, but sand, the case is not possible, because without sigma 3, sand will not be erect. Okay, so C will be coming with the tangent we apply and we will get the C. Okay, this is B, delta U, change in pore water pressure with delta sigma C, change in the cell pressure, and A is the change in pore water pressure with respect to the change in deviatrix stress. How much deviatrix stress we are changing and corresponding how much delta U is changing. Okay, now guys, the retaining wall. Okay, these are the retaining wall, guys, and there are three conditions. One is rest condition, when the retaining wall is not moving anywhere. Active condition, when the retaining wall is moving towards the soil. Passive condition, when the retaining wall is moving away from, rest condition, when the wall is not moving anywhere. Active condition, when the wall is moving away from the soil, and passive condition, when the wall is moving towards the soil. Okay, now guys, like this is retaining wall, this is ground level. So if it is here only, it is the rest case, it is here only. So here, if vertical stress is sigma V, the horizontal, in earth pressure chapter we find horizontal stress. It is not like in water, what is there at H height below, the pressure is gamma WH in all direction. At H height below in water, the pressure gamma WH is in all direction. But soil is not as homogeneous as water. Soil is not as homogeneous as water. Okay, here the pressure at different locations or pressure at different directions are different. So vertical stress is sigma V, that is gamma into H, whatever, gamma dry to gamma dry into H. If it is saturated, so gamma saturated into H, like this. And the horizontal stress we want to find out. So when it is rest condition, so sigma H is equal to K naught into sigma V. and K naught value is 1 minus sin phi. This is active earth pressure coefficient at rest. Okay, so horizontal stress is K naught of sigma V. Now, if this is the retaining wall, this is the ground level, and the wall is moving away from the fill. Okay, in active case, this movement is 0.2% to 0.5% of total height for movement of full active pressure. And for passive case, this movement will be towards the soil, that is 2% or 5% of total height for the full movement of passive earth pressure. So here, at this point, if vertical stress is sigma V, so horizontal stress is Ka into sigma V, and Ka value is 1 minus sin phi upon 1 plus sin phi. This is the horizontal. Similarly, for passive case, when wall is moving towards the fill, it is Kp into sigma V, and Kp is 1 plus sin phi upon 1 minus sin phi, and Ka into Kp is 1. Ka is less than 1. You can see numerator is smaller, denominator is bigger. Kp will be greater than 1. 1 plus sin phi, numerator is bigger and denominator is smaller, 1 minus sin phi. So of course here Ka is less than 1. So horizontal stress is minus stress and this is major stress. Okay, in Kp condition, sigma h is equal to Kp into sigma V. There Kp is greater than 1. So this will be the major stress and this is the minor stress. Now all these formulas are not correct, guys. Let me tell you why. Because guys, the real what I am telling you till now, that sigma h is equal to Ka into sigma V, or for passive condition I am telling you it is Kp into sigma V, but that are only valid for C is equal to 0 case. When the soil has this cohesion also, let me tell you guys, the formula will be Ka into sigma V minus 2C root Ka for active case. For cohesionless soil, C is 0. So that is why I am writing directly like this. Sigma h is equal to Ka sigma V. Similarly, for passive case, the horizontal stress at any level is Kp into sigma V plus 2C root Kp. This is for passive case. When cohesion is 0, then sigma h is Kp into sigma V. Like this. Okay. Okay, friends. Now, the depth of excavation up to which we can excavate without failure is the depth of excavation. Okay, it is 2z naught, the critical height. This is 4c by gamma root Ka. Up to this height, we can excavate excavation. After that, bracings are required. Up to this height, critical height 4c by gamma root Ka, there is no bracing required. There is no bracing required. Okay. Okay, friends. Give me a yes or no. Everyone. कुछ तो इज्जत रखा करो टीचर की भाई. ओके, चलो आगे चलते हैं. तो ये आपके पास था. ओके, एक्टिव पैसिव फाउंडेशन. फिर अपन ना एक वर्टिकल स्ट्रेस बिलो सॉइल बच गया, फाउंडेशन बच गया, शैलो डीप और स्लोप स्टेबिलिटी बच गया. फिर ये किसी और क्लास में अपन कर लेंगे. ठीक है, ये फिर अपन किसी और क्लास में कर लेंगे. ओके ओके गाइज, कुछ यस नो तो बोल दिया करो. कुछ यस नो तो बोल दिया करो भाई. ठीक है, ये अपन किसी और क्लास में कर लेंगे. अच्छा, कल ना संडे का फंडा आएगा मेरा. दिस विल बी एट 10:30 AM इन मॉर्निंग। ओके, मॉर्निंग में रहेगा ये। देखो आपने ना जब गए होंगे तो आपको दो टाइप के फ्लाईओवर्स दिखे होंगे। एक नीचे खाली रहता है, एम्प्टी, दिस सपोर्टेड ऑन द कंक्रीट, दिस इज सपोर्टेड ऑन द कंक्रीट ओनली, ऐसे कंक्रीट पे है। और एक दूसरे टाइप का रहता है जिसमें नीचे कोई गैप है ही नहीं भाई, इसमें पूरा नीचे सॉइल है और इस सॉइल को यहाँ पे रिटेनिंग वॉल से कर रखा है, सॉइल को रिटेनिंग वॉल से रजिस्ट कर रखा है। तो ये दो टाइप के रहते हैं, करेक्ट करेक्ट, ठीक है। एक तो ऐसा ओपन वाला, एक में सॉइल रहता है। तो इनका डिफरेंस क्या है और कब कौन सा, किस साइट के लिए मैं कौन सा सिलेक्ट करना चाहिए, किस साइट के लिए कौन सा सिलेक्ट करना चाहिए, ये मैं आपको कल संडे का फंडा में 10:30 AM मॉर्निंग पे बताऊंगा। ओके, दूसरी बात, थैंक यू थैंक यू थैंक यू गाइस। चार्ट सेपरेशन का ऐसा कोई रीजन नहीं है। एक और चीज बता दूं यार, एक बस हल्का सा ना वो रह गया है हमारा, वर्टिकल स्ट्रेस बिलो सॉइल, ठीक है। एक रह गया है फाउंडेशन और एक रह गया है स्लोप स्टेबिलिटी। तो नेक्स्ट कभी अपन ये तीनों चैप्टर का भी कर लेंगे, ठीक है। नेक्स्ट अपन कभी इन तीनों चैप्टर का भी कर लेंगे। हेलो, थैंक यू दीपक सर। ओके, कैसा लगा आपको आज का क्लास? ठीक है, ये तो आपके पास होने वाला है कब, कल 10:30 मॉर्निंग पे। एक कल शाम को ही 8:30 PM पर, 8:30 PM पर कल शाम को ही, संडे को ही यूट्यूब पर ही, क्योंकि इंजीनियरिंग सर्विसेज के रिजल्ट्स तो 7 अगस्त को ही आ गए था आई गेस, लेकिन इंटरव्यू डेट्स भी आ गई है। तो 4 मेंबर यूजुअली रहते हैं जिसमें से एक चेयरमैन होता है। कैसे कैसे टाइप के क्वेश्चन पूछ सकते हैं, कितना समय होता है, अगर आपको कभी आंसर नहीं आया तो क्या रिप्लाई करना है, क्या क्या चीज प्रिपेयर करके जानी है, डैफ फॉर्म में क्या क्या चीजें आपके डैफ के आधार पर वो पूछ सकता है, ये सारी चीजें कल मैं आपको इस सेशन में बताऊंगा, ठीक है। तो ये आपके पास होगा कल, ठीक है। और सर्वे का कंप्लीट फॉर्मूला मैराथन ये आपके पास होगा, कब होगा, मंडे को। दिस विल बी ऑन मंडे। सर्वे का इतना सवाल जितना बड़ा नहीं होगा, जल्दी हो जाएगा, और सवाल भी जल्दी हो जाता, लेकिन आज थोड़ा हमने गलत स्ट्रेटेजी कर दी, थोड़ी सी आज हमने गलत स्ट्रेटेजी कर दी। थोड़ा मैं फॉर्मूले से स्ट्रिक्ट होके ना थोड़ा दूर भी चला गया शायद, नहीं तो वो 2-3 चैप्टर जो बचे थे वो भी हो जाते। थोड़ा फॉर्मूले तक ही सीमित रहना था, मैं थोड़ा कॉन्सेप्ट में ज़्यादा घुस गया, ठीक है। तो अदरवाइज ये मंडे को होगा आपके पास 8:30 PM पर, ठीक है। मूज बना दूं क्या अपनी? ओके, ठीक है। अच्छा हाँ, स्कॉलरशिप टेस्ट आपके पास है 9 AM to 9 PM 3 सितंबर को, जहां पर आपको 90% डिस्काउंट मिल सकता है अगर आप बायजूस एग्जाम प्रेप कोर्सेज ज्वाइन करना चाहते हैं। 90%, 80%, 70% डिपेंडिंग अपॉन योर मार्क्स। फ्री है, अगर आप ज्वाइन नहीं भी करना चाहते तब भी आप दे दीजिए, ताकि आपको ऑल इंडिया लेवल पे अपनी रैंक पर चल सके। दूसरा, मैथ्स में 13 आउट ऑफ 13 कैसे आ सकते हैं, कैसे आप मैक्सिमम फायदा उठा सकते हैं, ये राकेश सर आपको एक वर्कशॉप में बताएंगे। कहाँ है? हाँ, 6 सितंबर को 7:30 PM पर बायजूस की ऐप पर, ठीक है। तो प्लीज डू रजिस्टर फॉर दिस वर्कशॉप। हेलो संतोष, अब तो हो गया पूरा, हलवा बना था सब लोग खा के चले गए, अब आ रहे हो आप, अब आ रहे हो पूरा सवाल 2-3 चैप्टर छोड़ के हो गए सब, ठीक है। विजन कोर्सेज हमारे पास इंग्लिश और हिंदी दोनों में ही है, 24 बैच के लिए भी और 25 बैच के लिए भी। अगर आप एनरोल करना चाहते हैं तो मैं तो आपको पहले रिकमेंड करूंगा कि स्कॉलरशिप टेस्ट दें, ताकि आपको डिस्काउंट मिल जाए, ठीक है। उसके बाद आप यहाँ पे एनरोल करके अपनी क्लासेस प्रिपेयर कर सकते हैं। टेलीग्राम ग्रुप ऑलरेडी मोर देन 5000 स्टूडेंट्स हैव जॉइंड दिस, ओके। तो यहाँ पे आपको सारी अपडेट्स मिल जाती हैं, तो आप इसको प्लीज ज्वाइन कर लीजिएगा अगर अभी तक नहीं किया है, ठीक है। फिर से बता दे रहा हूँ, कल संडे का फंडा, यूजुअली संडे का फंडा मेरे शाम को आ रहा था, पर कल ये 10:30 AM पे होगा भाई, मॉर्निंग पे, तो इसको मिस मत करना, ठीक है, ठीक है। और ये होगा कल 8:30 PM पर। तो सुबह टपकूंगा यूट्यूब पर 10:30 पे, और शाम को 8:30 पे आपके पास क्रूशियल 40 मिनट्स ऑफ इंजीनियरिंग सर्विसेज इंटरव्यू गाइडेंस प्रोग्राम। ठीक है, चलो एक बार सारे चैप्टर देख लेते हैं फटाफट से। कहाँ गया? हाँ ठीक है भाई, ये आपके पास चैप्टर थे ना। तो आप ये समझिए कि अगर आप प्रिपेयर कर रहे हैं तो आपके पास प्रॉपर्टीज ऑफ सॉइल से क्वेश्चन आए तो बहुत अच्छी बात है, नहीं भी आए तब भी पूरे सॉइल में आपको उसका यूज होना ही होना है, तो उसको आपको मिस नहीं करना है। इफेक्टिव स्ट्रेस, परबिलिटी, सीपेज, ये सब उन टॉपिक पर टिक कर रहा हूँ जहाँ से क्वेश्चन आने के आपके मैक्सिमम चांस हैं। मतलब अगर 15 मार्क्स का सॉइल आता है तो 10 मार्क्स का ये जो मैंने टिक लगाए हैं यहाँ से आपके पास आता है। ठीक है, कोई डाउट है तो पूछ लो। अच्छा, क्विक साइन कंडीशन का भी नहीं किया ना भाई हमने। क्विक साइन कंडीशन का फॉर्मूला हमसे मिस हो गया। दिस इज द क्रिटिकल ग्रेडियंट एट विच, क्विक साइन कंडीशन का कर लेते हैं फटाफट। सिग्मा बार नेट इज इक्वल टू सिग्मा बार ओल्ड, दैट मीन्स हाइड्रोस्टैटिक प्रेशर, प्लस माइनस HL इंटू गामा W, है ना। अपवर्ड सीपेज के लिए आपके पास माइनस होता है, डाउनवर्ड सीपेज के लिए प्लस होता है। और अगर अपवर्ड सीपेज है तो मतलब जीरो हो सकता है। देखो डाउनवर्ड सीपेज में तो इट इज एडिंग, सो नेवर इट विल बी जीरो, बट इन अपवर्ड सीपेज इट इज माइनस, सो इट कैन बी जीरो। सो एट क्रिटिकल ग्रेडियंट this effective stress becomes zero, and effective stress becomes zero, that means it is this condition, quick sign condition. Particles has no strength. The effective stress means contact pressure, that means no strength particles has. Okay, when this occurs, when the gradient becomes this g minus 1 upon 1 plus e. If you put e is equal to n upon 1, n upon e is equal to n upon 1 minus n, you will be getting like this also. Okay, and factor of safety is IC by I. This is the gradient at which this condition will be happening, like this man is having. Okay, now Q through a flow net is K, Q through a flow net is K into head loss into number of flow fields upon ND. Q is equal to K into H into NF by ND. So sigma bar, as you written na here, sigma bar net is equal to sigma bar old, assuming it to be hydrostatic pressure, plus minus HL gamma W. Or you can write simple also, like earlier, sigma minus U also you can write, it will be same answer. But here the U should be the actual, not hydrostatic pressure. Here U should be the actual pressure. Okay, thank you guys. तो कल मिलते हैं आपसे फिर संडे का फंडा में सुबह, इंटरव्यू गाइडेंस में शाम को। थैंक यू गाइस, टेक केयर।